A tree is a graph that is connected and has no circuits. All trees must have the following properties. There is only one and only one path joining any two vertices. Every edge is a bridge, and a tree with n vertices must have n minus 1 edges. If we look at the examples we have, the first one is an example of a tree. The second one is an example of a tree. Also this one. While this one, notice it has a circuit, so it's not an example of tree. And this one is disconnected. To a disconnected graph is not an example of a tree. We can fix the ones that are not trees to become a tree by removing one edge. Now every edge is a bridge, and we can connect this one, so this one will become a tree. We said that every graph with n vertices must have n minus 1 edges. So if I look at the one on the left, it has 6 vertices, therefore it has 5 edges. And the one on the right, it has 15 vertices, therefore it has 14 edges. Usage of trees. We use trees in computer science in representing hierarchy of data, in statistics. A subgraph is a set of vertices and edges taken from the original graph. We have a graph. Let's see some examples of subgraphs. And we can draw many subgraphs. But another example also. So these are examples of subgraphs. Now, if a subgraph that has all the vertices and is tree at the same time of the original graph, we call it a spanning tree. So let's see examples of spanning trees. That's one example. Another example. So these are examples of spanning trees, and we can find many spanning trees. We have a graph, and we need to find a spanning tree out of this graph. So if I observe my graph, it has 8 vertices. Therefore, my spanning tree should have 8 vertices with 7 edges. My graph, this one, has 12 edges, so we only need to remove 5 edges. Because the spanning tree should have 7 edges, so by removing 5 edges, we got a spanning tree. Now, which example here is a spanning tree to the given graph? It's A, but we can fix B to become a spanning tree by removing one edge. We can fix C to become a spanning tree also to the given graph by removing one edge. And D, we can connect the graph. So now all choices are spanning tree to the given graph. So in this example, we need to find the minimum spanning tree using Kruskal algorithm. So first of all, a minimum spanning tree is a spanning tree with the smallest total. Using Kruskal algorithm indicates that choose the edge with the smallest weight, mark it red, then choose the next smallest edge and mark it red, and the next smallest edge, mark it red. Keep the process until you get a spanning tree, and then the spanning tree you obtain is going to be of a minimum sum or a minimum weight or a minimum total. So for example, in our example here, the edge with the smallest weight is 24. Then we're going to choose the one that is next, which is 37. Then the next smaller one is 42, then 59, then 63, and then 65. Now we have a spanning tree, and if we add the weights, we're going to have a spanning tree with the minimum weight. So we use Kruskal algorithm. Another example where we have to use Kruskal method. So first we're going to start with the edge with the smallest weight, which is 1. then 2, we have another 2, so we have to take it, then 3, then 5. Now I can't take this 6, or we can't take this edge because it's going to cause a cycle. Also, we can't take this 7 because it's going to cause a cycle, but we can choose this 7. Now we're going to add the numbers because we got already a spanning tree. So the minimum spanning tree is 20. Let's see the red part if it's a tree. And don't forget the weight of the edges.